Okay, everybody, let's get started. So today's topics are arrays in Bash and functions in Bash, both of which are very strange, like everything else. Okay, so Bash has one-dimensional arrays. They are only one-dimensional arrays, so there's no such thing as a multi-dimensional array in Bash. They're indexed using, you have two types. One is indexed using an integer index. And then there's what's called an associative array. So you can index using a string. So that looks like a Python dictionary or a Java map. Now, the associative arrays are only available in Bash 4.3, which is it's not that new. But if you're using a Mac, your Mac is probably on Bash 3 point something, 3.2 or something like that. So you won't have them on your Mac unless you upgrade Bash. So I'm actually not going to talk about associative arrays. We're just going to use the indexed ones. But even the indexed ones are, you should probably think of them as being associative arrays where you're using an index to access elements of the array. You'll see why I say that in a second. Okay, so like other Bash variables, you can create an array just by creating a variable, right? And it makes the array for you automatically. You can also use the declare command, and I'll show you how to do that in a second. And then if you want to, so if you know what the elements of the array should be, you can use a single set of round brackets and put the elements inside the round brackets. Right? Okay, so indexed arrays. These are the only ones I'm going to talk about. The associative arrays work the exact same way. It's just the index is a string. Right? So indexed arrays are zero-based, but that does not mean the first element in the array is at index 0. It only means that 0 is the smallest starting index. Okay? So that's the smallest starting index that you can use. It's 0. Now, there is no requirement in Bash that you start filling in the array starting at index 0. Right? So you can start filling in the array at index 1,000,000 if you want to, and Bash is perfectly happy with that. Furthermore, there's no requirement that indexes be contiguous. So contiguous means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So everything's filled in order. Right? There's no requirement that that be true either. Right? So you can fill in the array at element 5, and then 12, and then 17, and then 2, however you want. It doesn't matter. Right? It's very strange. Okay, so here we go. Here's making arrays. So this is this is just creating variables that are array variables. And Bash makes the array for you. Right? So if you write a square bracket 0 equals hello, that makes an array whose element at index 0 is the string hello. Right? B1 equals goodbye makes an array called B whose element at index 1 is the string goodbye. There is no element at index 0 in B. Right? C100 equals weird. Well, that's written for a reason. Right? So that makes an array C whose element at index 100 is the string weird. There's no elements 0 through 99. Right? You can start wherever you want. Okay? So it's very strange. Now, the square brackets are problematic because they're used for other things in Bash, right? So you have to watch out when you do something like this, right? So let's try that out, and we'll see what happens. Okay, so I want to make an array A, right? It's going to be hello, right? And now I want to echo the value at A0, right? Let's put these in quotes to prevent any white space breaking. Now, you do not get hello. You get hello 0, right? The problem is the square brackets, they have a different meaning in Bash, right? So in order to get this array out properly, or in order to get that element out properly, you need to put the whole thing in braces. And now you get hello. Okay? So very weird, but that's what you have to do. So when you're working with these arrays, when you want to start accessing elements of the array, make sure you use the braces around the array name and the index. Right? I'll explain why you get hello square bracket 0 towards the end of the lecture. Right? Okay, so if you so you can do indexing in the normal way, right? So you're used to doing this sort of thing in Python and Java, right? With Java arrays, Python lists, right? The indexing works the exact same way. I don't remember which version of Bash allows you to use negative indexes. So like Python, you can index from the back of the array using a negative index. But I can't remember which version of Bash that was introduced in. So if you're on Windows, it probably works. If you're on Mac, it may not work unless you upgrade bash. Right, so this is strange, right? Everybody agrees this is a little weird, right? So you have to get used to this. Okay, you can use declare as well. So declare minus a, little a, will make you an array, an index-based array, right? So that makes an array X, that makes an array Y, that makes an array Z, and then you just go ahead and use it as though it were an array, right? There's no advantage to doing it this way. You can do it this way if you like, right? And then finally, if you happen to know the elements that you want to put into the array, you can use round brackets, right? So array 1 equals round bracket hello makes an array whose element at index 0 is hello. Right, so array 1 equals, hello, right, echo dollar squiggly bracket brace ARR1 0, right, that will print out hello, okay? Okay, now, if you want to set the indexes, you have to use this strange notation where you put the index in square brackets and then you write equals and then the thing you want. Right, so array 2 is the array that has one element goodbye, and that element is sitting at index 1. Right, so let's try that. Array 2, right. Round bracket 1 equals, I don't remember what I put in there. Let's do that. Right, and then, okay, so let's see what happens if we echo out the array element at index 0. Right, you get nothing, right, because array 2 only has one element in it and it's sitting at index 1. Right, so there's nothing at index 0. There is something at index 1. There's nothing at index 2. Notice you don't get an error or an exception or anything like that. Right? Bash doesn't do anything to check if the index is valid. Right? Now this one lets you set 3 elements of the array. Right? Again, bash doesn't care what order you go in. Right? So round bracket square 100 equals weird. That means array 3 at index 100 is the string weird. Right? Array 3 at index 0 is weirder, and array 3 at index 1 is weirdest. Right? So again, bash doesn't care what values you give. Bash doesn't care what order you specify the indexes in. Right? And this is why I said you should probably think of arrays as associative arrays or dictionaries or the equivalent of Python dictionaries. Right? These indexes, yes, they look like integer indexes, but they're really just keys. Right? And every key is associated with a value. Right? So you're probably better off thinking of them as Python dictionaries. I mean, the type's called dict, so you know when I say dict, it's gonna sound the way it sounds. All right, now so you've got these weird subscripts at and star when you work with arrays. All right, so what these things do, if you write $ brace array square bracket at, right, or $ brace array star, you get the same thing. Right? So these produce an expansion of the elements in the array. Right? So whatever elements in the array, whatever strings you have in your array, you end up with the same expansion. So what you get is a list of all the elements in the array. Okay? Now, there's no double quotes around this, right? So both of them, you get the same result, right? So everything that, you get a list of all the elements that are in the array. Right? Okay. If you put the double quotes and use the @ sign, right, that produces a list of all the elements of the array where each element is expanded as a separate word. All right, so keep that in mind. So each element is expanded as a separate word. We'll show you an example of all these in a second. Right? If you use the quotes with the star, that gives you one string, right? One string where all the elements of the array are in that string. Right? You get back one string. Right? That gives you back a list, right? So it gives you back multiple strings, right? And up here, you also get back multiple strings, but you're not inside the double quotes, right? And remember, the double quotes prevent white space breaking, right? Okay, So here's the slide that shows you the difference between all of these. I have the array January, February, March, April, right? I'm going to loop over the elements in the array, right? So for I in $months, so no quotes around the months, and I'm using the star, right? So what $months star gives you is this string, is the list. So that's going to give you the list January, February, March, and April, right? With a space between each string. Okay, that's what it's going to give you. So when you loop over that, you should get January, then February, then March, then April on a separate line, right? Okay, so hopefully this works. Up here. Okay, and that's what you get, right? So you get, right? So you get January on one line, so it echoes out January. New line, it echoes out February, then March, then April, right? Okay, now I told you that if you don't use double quotes, then these produce the same result, right? So if I change the star to an at, you get the same thing, right? Now if you use double quotes, that's when you get something different. Okay, so if I use double quotes and the at, right? Double quotes and the at, you're going to get each word separate. You're going to get each word as a on its own. Okay? So you get each word on its own, so you get the same thing, January, February, March, April. Right? If you use the star, you get one string. Right? So if you use the star, you end up with the string that looks like that. Right? And so when you loop over that string, right, there's no white space breaking because you get the double quotes. Right? So all you get is the string itself. Right? So now you just get January, February, March, and April. All right? Now you might ask, okay, so why do you care if they're quoted or not? Because sometimes you have to quote. Right? So that's the next slide. Okay, when do you have to quote? Well, you have to quote when your array has elements that contain spaces in them. Right? So here I've got the array that's got three elements, right? It's a dog, a cat, and a fish. Right? And I'm going to do the exact same thing. Boop, boop. Okay, so let's paste that in. All right, so we got a dog, a cat, a fish. And now when I loop over that string, right, I get a, then dog, then a, then cat, then a, then fish. Right? Now why do you get that? Because when you use no quotes, right, you get a dog. What's the order of these? Dog, cat, fish. Right? A dog, a cat, and a fish. Right? So to bash, that looks like 1, 2, 3, 4, 5, 6 separate words. Right? Which is why you get a, then dog, then a, then cat, then a, then fish on separate lines. Right? No quotes. Right? So this gives you the exact same thing. Right? Now if you quote, this is where the difference shows up. So if I quote, right? When I quote, this thing gets stuck. When you quote and you use the at, you get that. So you get 3 quoted strings. Right? So now you get a dog, a cat, a fish. Right? And if you use the star, right, you get the single string, a dog, a cat, a fish. Right? So that's the difference. Right? Here I have to quote. If I want to get if I want to get this output, right, then I have to quote. Right? And that's why you have the 2 different outputs in this case. Right? So that's why there's a difference between when you quote the at and the star symbol. Okay, now how about the number of elements in the array? Right, so the number of elements in the array you use the pound or dollar or number sign in front of the array, right? And inside as the index, you use either the @ or the star, right? So remember the array name with a star or an @ in it gives you the elements of the array, all the elements of the array, right? The number of elements is just the you get by putting the number sign in front, right? So A has the, up here, A is the array with one element in it. So that will output 1, right? Now B1 equals goodbye. Remember, so that's an array B whose element at index 1 is the string goodbye, right? If this was any other language, this would be an array of length 2, but it's not. It's bash, so it's an array of length 1, right? So for example, do I actually have a B? I don't remember if I have B or not. Have I done B? Echo dollar. Apparently not. So B1 is goodbye. Okay. Oh wait, I might. B1. Right. So now if I get the length of that, so how do I do this? I do that, that B at. Right. So it really is an array of length 1. Right. It's only got one thing in it. Right. C100 equals weird. That's an array of length 1, so that'll print out 1. Months is an array of length 4, so that'll print out 4. Right. So when you want the number, it's the, I guess, the pound or the number sign in front of the array. Right. Okay. Now, because you can, because you don't have to start indexing at 0, right? You may want to get the indexes that are actually used by the array, right? So to get the indexes used by the array, you use the exclamation mark in front of the array name, followed by the square brackets, followed by @ or star, right? So A equals 1, that makes an array A whose element at index 0 is 1. So that will print out 0, right? So that uses the index 0, right? B1 is goodbye, so that'll print out 1 because it uses index 1. Right? C100 equals weird, that'll print out 100 because it uses element 100, the indexed element 100. This one here starts numbering at 0. So 0, 1, 2, 3. So that's what you'll get here when you echo the indexes used by months. Right? You'll get 0, 1, 2, 3. Right? So if we echo, months. Right, 0, 1, 2, 3. Right. Okay, now the reason you might want to get the indexes is because you may want to write a loop where you access the elements of the array by index. Right. So that's one reason why you might want to get the list of indexes. Right. For example. Right. So for I in, now remember the exclamation mark months means the indexes of the array. So that'll give you for I in 0, 1, 2, 3. Right? Do, right? So I can get the element out just by using array indexing. Right? And then you can echo out the element. So you'll get January, February, March, April in this case. Right. Okay, if you want to add, now the fact that you can use any index you want in an array means you don't really know what an index is at the end of the array, right? So if you want to append something to the end of the array, the way you do that is with plus equals, right? So here I have the array months, right? So January, February, March, and April, right? When you use plus equals, you should always append an array, okay? So if I want to add the month May to the end of the array, I write months plus equals round bracket May. Right? What that does is it makes a new array that has January, February, March, April, May in it, and then assigns that back to months. Right? So if you echo out months at, you'll get January, February, March, April, May. Right? And then if you add the array June, July, August, right, that'll add June, July, and August to the end of the array. right? And then when you echo that out, you'll get January, February, March, April, May, June, July, August. Right? So copy all that. And there you go, right? So January, February, March, April, May, June, July, August. Now, what you have to be careful about, right, is the following, right? You cannot append an element to the end of the array. Right? It doesn't work, right? So I just want to append a single element, right? Notice here, when I appended May, I used an array, right? So I appended an array to the end of the array. Here, I'm going to try to append a string to the end of the array, right? And that doesn't work. So, well, it does something. So I'm going to append September, I think, right? So I think I've just added September, but when you output the months, you end up with Jan, September at the front, which is weird, right? You don't end up with January, February, March, April, May, June, July, August, September, right? You get Jan, Sep. So what's happened is the first element of the array has changed. Oops, sorry. Where do I talk about this? Somewhere, hang on just a second here. Okay, so we'll explain that shortly too. Right, so we'll explain that one in a second. All right, now what if you want to sort an array? Because sorting is very powerful, right, in many computing problems. Right? It helps you find a more efficient solution. Now there's no way to sort an array in Bash. Right? So Bash has no built-in way to sort. Not to sort an array anyway. But what you do have is you got this sort command that will sort lines of text. Do you have a question or are you stretched? Okay, so that will sort lines of text, right? So can you use the sort command to sort the contents of an array? So the answer is yes, as long as the array doesn't have any unusual characters in it. So as long as the elements of the array don't have spaces or anything that expands like a wildcard, right? This will work. Okay, so for example, if you have an array of numbers, this will work fine, right? So the idea is, I want to try to use sort to sort the elements of the array, right? So I'm going to use a loop to print out the element of the array on separate lines, right? One element per line. And I know sort can sort that, right? So if I take the output of the loop and pipe that into sort, sort will sort the lines so that it ends up in sorted order, right? So I can get the sorted. I can get a sorted list of elements line by line, right? Now the problem is I need to store that result somewhere, right? So you can do that in Bash, right? You can capture standard output of sort using a command substitution. Right? So this was a week or so ago. We might have been longer than a week ago now. Right? So I showed you that you can capture the result of a command in a variable. Right? And you do that by using command substitution. So we're going to see that in a second. Right? And now that I have that list of elements, I can feed that list into the round brackets to create an array containing those elements. Right? So what does this look like? It looks like this. It's surprisingly short. But it's also quite complicated to understand. Okay, so my script here is going to use read to read in some elements into an array. Right? I'm then going to echo out the elements of the array so that you can see what it is we've typed in, right? The list of elements. Okay, now I want to use a loop. Right? So ignore the dollar round bracket for a second, right? I'm going to use a loop. So for each element E in my array, right, I'm going to echo E to standard output. Right? So I'm going to print the elements of E one line at a time. Right? And then done, so that ends the loop. Right? So that's just a command in Bash. Commands in Bash just generate strings. Right? So this produces a string that goes to standard output. I can pipe that output into the sort command. Right? And sort will sort the rows for me. Right? And then if I put everything in round brackets and slap a dollar sign in front, right, that's command substitution. Right? In other words, I can grab the results of all of this pipeline, right, which is just a string, and I can store it in a variable. Right? So elems is now the variable that holds the contents of that pipeline, right? The output of that pipeline. Right? What am I going to do with that string? Well, I'm just going to shove the string into a list, into an array. Right? when you put that string into the array, right, bash does white space breaking, so all the new lines become separators, right? And what you end up with here is the elements of the array separated with a space, right? So that produces a new array called sorted, and now sorted is your array of sorted elements, right? Elems, array, ARR. So ARR is not sorted, right? ARR is the original array. Sorted is the elements of ARR in sorted order. Right. So does this thing actually work? A sort. Wait. Oh, is it here? It's not here, is it? I forgot to copy this one too. Okay. Do I want to try this? I don't really want to. I don't want to try cutting and pasting it because I know it's not going to work. This does work. So this will actually work unless you put an element with spaces or wildcards when you enter in the list of elements. Right? The reason if it doesn't work when you put in the elements with spaces or wildcards is because here. Right? When you write $elems with no double quotes around it, that you end up with white space breaking. Right? So any elements with spaces in between, these become separate elements in the array. Right? If you have a wildcard up here, like a star or a question mark, those become file name expansions. Right? So now you end up with file name expansion happening here as well. If you quote this, right, so if you try to quote elems to get around that problem, that doesn't work either, right? Because elems is the string with a bunch of line breaks in it, right? So what you end up with is one string. You end up with an array with only one string in it, right? So this sort of works. If you want to find an answer that actually works, you can do a little Google search for it. It's a little more complicated. Okay, unset. If you want to delete an array, you just unset the array. Right? So if I make the array A, B, C, D, right, and then unset it, that array becomes empty. Right? In other words, it doesn't exist anymore. Right? You can also unset an element of the array. Right? So I can remove an element of the array by using unset, and then you have to quote the element that you want to remove. Right? So unset quotes array square bracket 0 will remove that element from the array. Right? And I guess we should run this so that you can see what it looks like. So array right, you have the array of 4 elements. If I unset the array, right, the array is gone. Right, make the array again. Now I want to remove element 0 from that array. Right, so the A should be gone. Right. Now the question is what happens to the indexes? So the element at index 0 disappears, right? But the element, the remaining elements, they still have their original indexes, right? So in other words, no shifting happens like would happen in Python or Java, right? If you remove an element from a list in Python or Java, the elements all shift down one index, right? No index shifting happens here. Okay, now there were some weird results in some of these slides, right? So back here, for example, this one, right? So remember when we did this, you ended up with hello followed by square bracket 0, right? Which is why we had to put in the braces. The reason you have to do that is because of this. So if you make a reference to an array variable without using a subscript, right, then as far as bash is concerned, that's a reference to the element at index 0 of the array, right? So here, months is your array, January, February, March, April. If you just echo out months, bash thinks you want the element at index 0 of months, right? So you get January, right? if you just write months equals nothing, that's the same thing as writing months square bracket 0 equals nothing, right? So, well, let's see what happens when we do that. Right, so months equals okay, let's just make sure that it's actually right. Okay, months at, right? Oops. What did I do wrong? Oh, thank you. Square bracket at, there we go. Okay, so there we go. Now, if you just echo out months, that gives you January. So that's the element at index 0, right? So that's the same thing as writing that, right? Now, when I write that, right, you end up with January square bracket 0. Why? Because at months, right, on its own is the element at index 0 of months. So that's January. And then square bracket 0, that's just a string as far as bash is concerned, so it sticks that on the end. Right, so that's a little weird. What's going on here? Oh, months equals. Okay. So months equals, right, does not nuke the array, right? Instead, what it does is it removes the first element from the array, right? Or actually, it sets the first element of the array to nothing, right, to nil, right? So is it still there? It's still there, right? The element at index 0 is still there, right? So that doesn't actually do, that doesn't do what you think it ought to do, right? Okay, what else is going on here? Right, that's good. That's what I wanted to show you. Okay, so you have to be a little bit careful when working with arrays in bash, but they are usable and they're very useful. You just have to get used to the syntax, right? And watch out for the gotchas that I've indicated on the slides. Okay, functions. So a bash function is similar to like a Python function or a Java method, right? It's basically you're trying to group some commands so that the caller can use them later, right, by just calling the function name. The way you write a bash function is using either of these two. It doesn't matter which one you use, right? I believe the second one is the more common version, right? But if you want to, you can write function followed by the name of the function, right? Brace, and then commands inside the braces. Now, when you do this, though, you have the commands, the body of the function have to be separated from the braces by a new line, right? So in other words, there has to be a new line here, and there has to be a new line here after the commands, right? If you don't, bash gets confused about the braces being part of the commands, right? So you have to separate them. Alternatively, you can just write the function name and then round brackets, and then the body of the function, right? Either is acceptable. If you choose to use the function name, the round brackets must be here, right? If you choose to use the function keyword, then the brackets are optional after the name. Nothing goes in the brackets, so this is a little weird, right? Compared to Python and Java. So here's a simple function, right? I've got a script. It's got a function in it called greet, right? All greet does is print hello. How do you call the function? Well, you just write the function name, right? There's no round brackets or anything like that. It's just the function name. Right? So this is that, right? Right, so there's the function. Okay, so that's a simple function that doesn't do much. Now, the question you should be asking is, well, how on earth do I get information into the function, right? Because functions normally have parameters, right? At least in every programming language you've used, they've got parameters. Right? So how do you get information into the function? Well, one way is just to use the variables that are already in the script. So any variable that's defined inside the script but not in a function, yeah, oh, sorry, no, okay, but not in a function is considered to be global to the function, right? In other words, anything in the function can see that variable, right? So when I write var equals global, that's the string global, right? And then I call greet, right? So control flow comes up to here, right? So at this point, the variable var has been defined. It was defined here, right? So the script knows that the value of var is global, right? And if you, so that's function 2, right? Right there. No, function 2. Right? And so that indeed prints out that var is in fact global. Right? So that's one way to get information into the function. Right? Okay, now what happens if my function greet defines a variable called var greet, right? And sets the variable to the string greet, right? And then calls the function leave. Right? So we start here, var is global, go up to greet. Right? Does greet know what var is? Yes, right? Because it was defined here. Okay, then greet defines its own variable and calls leave. So we go to here, right? Does leave know what var greet is? The answer is yes, because it was defined up here, right? And so this will print out, what will this print out? It's going to print out hello, var is global. Goodbye, var greet is greet. And then it'll do var greet is greet, right? So now down here, the main body of the script also knows what var greet is because we called greet, right? And inside greet, we set the variable var greet. Right? So hello, var is global, so that's good, right? Here, right? So global set here, and then we go up to greet, right? So we know what var is. And then we should get var greet here, so we should get greet here. And we do. Goodbye, var greet is greet, right? And then when we come back to here, so when leave finishes, we come back to here, greet finishes, so we come back down to here, and now var greet is known to the rest of the script because it was set there. Right? So we should get greet on the end, right? And var greet is greet again, right? So that's how information is passed around when you use variables. Right? You have to be careful with this because remember, bash will create the variable for you the first time you use it, right? So for example, if I don't call greet here, right? So if I get rid of that line there and I call leave instead, right? You're going to get goodbye, var greet is the empty string. Right? You don't get an error or anything like that, right? Because var greet will get created right there, right? So you have to be careful about that. Okay, now you can make what's called a local variable, right? So a local variable shadows variables with the same name declared at different scopes. So what does that mean? Well, down here, right, in the main body of the script, we've got a variable called var. It's a global variable, so it's known everywhere throughout the script, right? Now we call greet. So up here, I make a local variable called var. So that's the same name as the variable here, right? Okay, so what happens is that variable here does not get changed. Instead, a new variable gets created up here with the same name, but it's local, right? Its scope is local to the method, to the function, and to any other function that this function calls. Right? So the scope of that var is local to the function itself. Right? So when you say hello var is blah, you get greet. But then you call leave. Okay? So now we jump to here. Right? And now leave also makes its own local variable called var. Right? And sets it to leave. Right? So this will, when this echo statement runs, it'll print out goodbye, var is leave, right? Control flow comes back up to here, right? Now greet is done, so control flow flows back down to here. And now down here, what's the value of var? Well, that was local, and that's local, so it doesn't change this one, right? And so this is still global, right? So I think that's 4. Let's just take a quick look at that. Right. So greet. up here, right? Hello var is. So when it prints out var the first time, it's getting the value of var from here, right? So you get global. It then creates its own. Wait, this is the wrong one. Did I skip a slide? Sorry. I must have. Oh, I did. Did I do this slide already? I think I skipped this slide, didn't I? Yeah, I did skip this slide. No, I didn't slip. Okay, never mind. This is what I want. Okay, so this is not. That was not 4. It's actually 5. Sorry. Okay, good. So that's fn5. Okay. So hello var is var. So it's greet, right? Because it's getting the value of the local variable var. Right? We jump down to leave. You're going to get goodbye is leave because again we made a local variable var, right? Whose value is leave. We come back up to here, and then we come back down to here, right? And then var down here is the global variable var, is the variable whose value is global, right? So that's how local variables work if you want to use them. Right? The only reason to use them is if you want to create a variable whose name happens to be the same as somewhere else. Right? Okay, now that's not the only way to get information into a function. Right? So this is only useful. Getting information into the function by passing around variables is only useful if the variables are already defined. Right? Instead, you can call a function using parameters, right? So using arguments, so you can pass arguments to the function, right? Now the weird thing in bash is that you don't actually say what the parameters to the function are, right? So when you write a function, it just looks like function round bracket, right? There's nothing in between the round brackets to indicate that it takes any parameters. But the function can take parameters. They're just not named, right? Which is a little awkward, to be honest. Right? So how do you get the value of the parameters inside a function? You use that, you use the positional parameters, just like we did in command line arguments, right? So $1, $2, $3, right? First argument, second argument, third argument, right? When you call the function, it looks just like executing a command with command line arguments. So it's function name, space, argument 1, space, argument 2, space, argument 3, space. So here's a little function called test, right? It wants 3 parameters, right? How do you get the parameters? $1, $2, 3, right? Those are not the command line parameters 1, 2, and 3, right? The command line parameters 1, 2, and 3 are in here, right? Inside the function, $1 means the first parameter passed to the function, the first argument passed to the function. $2 means the second argument passed to the function. $3 means the third argument passed to the function, right? $pound is the number of arguments passed to the function, right? Just like with command line arguments, right? And just like any other variable in bash, right? Param1, param2, and param3 will be created whether or not $1, $2, or $3 exists, right? So whether or not you passed in 3 parameters to the 3 arguments to the function, param1, param2, and param3 are still valid variables inside the function. Right? So all this script is going to do is going to call test with no arguments. It's going to call test with 1 argument. It's going to call test with 2, 3, and 4 arguments. Right? Let's do this and then that. Okay. Right? So when you pass 0 arguments to the function, right? Param1 is empty, param2 is empty, and param3 is empty. Right? But notice that the function still runs, right? Even though you called it with no arguments, right? If you pass 1 argument to the function, well, param1 gets set to that argument, right? And then param2 and param3 are empty. 2 arguments, right? The first 2 get set, but the third one doesn't. If you pass 3, then all 3 of them get set, right? If you pass 4, right? But you don't use $4 inside the function, right? then that fourth argument just disappears off into the ether, right? So if you don't use $4 here, it's like you never you're actually discarding that last argument that was passed into the function, right? Okay, so the return value of a function is the exit status of the last command executed by the function, right? So this is the other weird thing in bash, right? You're probably used to functions or methods that return values, right? A bash function doesn't return a value. Instead, what it does is it returns an exit status, right? So whatever the last command of your function was, the exit status of that command is the return value for the function. Now, sometimes you really want to simulate returning a value, right? So how does any command in bash work when you return a value, right? It prints something to standard output, right? So the way to return a value from a function is to print something to standard output, right? So you echo the return value to standard output. And then whoever's calling the function uses command substitution to capture the output. So here's the pow function written in bash, right? So pow is going to compute x raised to the power y, right? So the function is going to expect 2 parameters, right? The result is just x star star y, right? Because that's the power operator in bash, right? Dollar round bracket, right? Because this is a arithmetic substitution, right? And then you echo the result to standard output, right? Now, how does someone call the function? Well, they call the function pow, $1, $2, right? So they're going to pass, this is a command line, these are command line 1, command line argument 1, command line argument 2, right? Call pow, and then use a command substitution to capture the result, right? And then use the value of z for whatever you want, right? So here I'm just going to echo it out. And I think this is 7 if it's here. It is here. Okay, so fn 7. Okay, so I'm going to compute 2 to the power of 6, right? That's 64 apparently. Right? So that $1, $2 is that 2 and 6, right? That $1 and $2 is the 2 from here and the 6 from here. And then, right, so the key here, there's two important things here, right? Your return value is just whatever is printed to standard output, right? And then the caller, to get the return value, has to use a command substitution. Your assignment that occurred last night requires you to do this sort of thing a few times, right? So if you're wondering how on earth you get the result of something, you should consider perhaps using a command substitution to get the result from something. Right? All right. I think that was the last slide. Any questions? Yes?
About the assignment.
Yeah.
It says it's due during reading week.
Yeah, I'm going to have to push that one because the assignment came out very late.
Right.
Yeah. So I'll push it to the week after sometime. Yeah. Anything else? Okay.